Imagine you're a detective in a world of mystery, and the biggest puzzle is how AI thinks. Welcome to Neural Networks Explained Simply. Today, we're uncovering the brain behind AI that powers everything from your phone's camera to self-driving cars. Neural networks are like the wizard's spellbook of modern tech, mimicking our own brains but with silicon smarts. Picture billions of tiny decision makers working together. But how does it all start? It begins with inspiration from nature, our human brain. Neurons fire signals, creating thoughts and actions. AI copies this with digital neurons. Excited? Stick around as we journey deeper, starting with the basics of these incredible systems. What if I told you your next scroll on social media is guided by one? Let's dive in. Our story continues with the heart of it all, the human brain as AI's muse. You've got about 86 billion neurons up there, each chatting with thousands of others via synapses. Those are the bridges of information. When you see a friend, signals zip through, lighting up memories and smiles. Neural networks borrow this idea. Instead of biological cells, we have artificial ones, math-based units called nodes. They take inputs like pixels from a photo, process them with weights, think importance levels, and pass outputs along. It's like a relay race where each runner adds their twist. Simple, right? But layer these nodes and magic happens. In our detective tale, these are the clues leading to AI's smarts. Next, we'll see how they team up in everyday decisions, just like your brain picks Netflix shows. Now, let's make it relatable with an analogy. Imagine a group of friends deciding on pizza toppings. One friend loves pepperoni, he inputs his vote with high weight. Another prefers veggies, dialing it down. They discuss, adjust opinions, and boom, a group choice emerges. That's a neural network in action. Inputs are your data points, weights are how much each matters, and the output is the decision. For AI, this could be tagging a photo. Is that a cat or a dog? Nodes vote based on features like whiskers or ears. Our detective is piecing clues together, and it's getting exciting. These networks aren't random, they're structured in layers. Up next, we'll explore those layers and how data flows through like a river shaping canyons. Get ready to see the architecture that makes AI tick. Deep dive time. Neural networks are organized in layers like floors in a skyscraper. The input layer is the ground floor, raw data enters here, say, numbers from a sensor or pixels from an image. Then come the hidden layers, the real workhorses. Multiple levels process info, tweaking it with weights and activations, like adding spice to your pizza analogy. Finally, the output layer delivers the verdict. Yes, it's a cat. Each connection has a weight learned over time. Picture electrons buzzing through circuits, but in code. In our narrative, the detective enters the hidden rooms, finding patterns in the chaos. It's not just flat. Deep networks have many layers, hence deep learning. This depth allows complexity, from recognizing faces to generating art. But how do they learn? That's the thrilling part coming up, training that turns novices into experts. Learning is key to any brain, human or artificial. Enter training, the process where neural networks get smart. We feed it tons of examples, like showing a kid thousands of cat pics labeled cat. Initially, it's clueless, making wild guesses. But with each try, it calculates errors. How far off was that prediction? Then, magic backpropagation. Errors flow backward through layers, adjusting weights to minimize mistakes next time. It's like practice makes perfect. The network fine-tunes connections for accuracy. Our detective trains with clues, getting sharper. This uses math like gradients, but think of it as nudging a bike until balance clicks. Supervised learning is common, with labels guiding it. Unsupervised, it finds patterns alone. Billions of parameters get optimized, creating powerhouses. Next, we'll zoom into backpropagation's dance, the rhythm that powers AI evolution. Let's spotlight backpropagation, the learning engine. When the network outputs a wrong answer, say mistaking a dog for a muffin, it measures the loss. Then, like rewinding a tape, the error signal travels back, layer by layer. Each connection gets a tiny tweak, strengthen this weight, weaken that to reduce future errors. It's calculus under the hood, but visually, imagine ripples in a pond pushing boats into alignment. This iterative process, repeated millions of times, sculpts the network. In our story, it's the detective refining theories after each dead end. Activation functions like ReLU add nonlinearity, allowing curves in decisions, not just straight lines. Without this, AI would be basic calculators. GPUs speed it up, making training feasible. Feeling the power? Coming up, how these train nets tackle real tasks like spotting dangers in self-driving cars. With training complete, neural networks shine in action. Take image recognition, convolutional nets scan photos, spotting edges, shapes, then whole objects. Your phone's face unlock, that's a neural net matching patterns. Or voice assistants like Siri, recurrent nets remember context in speech. In healthcare, they detect tumors from scans faster than doctors. Our detective uses this tech to solve cases in seconds, but it's not perfect. Biases in data can lead to unfair outputs like misidentifying faces based on skin tone. That's a challenge we'll tackle soon. CNNs for vision, RNNs for sequences, transformers for language, they're specialized flavors. Imagine feeding a net your playlist, it predicts hits. This is AI democratizing expertise. Next shot, we go deeper into types and how they evolve, building our excitement toward the big reveals. We've built the foundation, now the deep dive peaks with architectures. Start simple, perceptrons, single-layer nets for basics like and/or logic, then multi-layer perceptrons add depth. CNNs dominate vision, filters slide over images like a detective's magnifying glass. RNNs handle time, remembering past inputs for predictions like stock trends. But vanishing gradients plagued them, so LSTMs emerged with memory gates. Enter transformers, attention mechanisms let parts focus on relevant bits, powering GPT models. It's like a team where everyone shouts but key voices amplify. Our narrative's detective assembles a dream team of tools. These evolutions make AI versatile from art generation to drug discovery, yet challenges loom. Overfitting, where nets memorize instead of learn, solved by dropout or regularization. As we climb toward insights, ponder, what if your biases shape AI? The climax awaits. Climax time, the insights that make neural networks revolutionary and risky. Key insight 1, scalability. More data layers mean superhuman feats like AlphaGo beating chess pros. But energy hogs, training one model guzzles power like a city block. Insight 2, interpretability. Black box problem, we see outputs but not why. Tools like saliency maps peek inside. Ethically, bias amplification. If training data skews male-dominated, AI hires perpetuate it. Our detective uncovers corruption in the system. Regulation calls grow, fairness, privacy via federated learning, yet the upside. Personalized medicine tailoring treatments. Emotionally, it's thrilling, AI as partner, not replacement. These nets learn like kids, growing with us. As tensions rise in our story, so does potential. Next, we'll confront the future, where neural nets reshape jobs and dreams. Building on insights, the future beckons. Neural networks will hybridize with quantum computing for unbreakable speed, solving climate models instantly. Edge AI brings smarts to devices, no cloud needed. Emotionally engaging. Imagine AI therapists understanding your mood via voice patterns, easing loneliness in our 20s, 30s hustle. In work, they automate drudgery, freeing creativity. Designers co-create with AI tools. Our detective envisions a partnership era. Challenges, job shifts demand reskilling, but excitement lies in augmentation. GANs generate realistic worlds, blurring real and virtual. Sustainability pushes efficient nets. For you, the viewer, this means empowered decisions with AI allies. As our journey peaks, feel the awe from brain mimicry to world changer. Wrapping insights, embrace learning, question biases. Next, real-life impacts hit home, showing how this tech touches your daily scroll. Now the climax reveals neural networks in your life. That Netflix recommendation, a net analyzing views. Spotify's playlists vibe with your mood via embeddings. In dating apps, they match compatibilities. Self-driving cars use them to detect pedestrians, saving lives. Healthcare apps spot skin cancer from selfies. For 20 to 35-year-olds, it's game-changing. Career tools like LinkedIn suggestions boost networks. Fitness trackers predict burnout, but watch for echo chambers in feeds reinforcing views. Our detective solves the case, AI enhances, doesn't replace human intuition. Key takeaway. These brains thrive on diverse data for equity. Emotionally, it's empowering tech as sidekick in your story. As we near the end, reflect, how will you use this knowledge? Final shot ties it with actionable steps, urging you to explore AI yourself. Our journey ends, but yours begins. We've demystified neural networks from brain-inspired layers to training dances and real-world wizardry. Takeaways, they're powerful tools mimicking thought but need ethical tuning. Start simple, try free tools like Teachable Machine to build your own net. Question AI outputs, advocate for fair data. For our 20 to 35 crowd, leverage this for careers in tech or just smarter living. Thanks for joining the Detective Squad on AI Explained Simply. If this sparked curiosity, like, subscribe, and comment your AI questions below. Next video, Transformers Unlocked. Hit notifications, more simplified AI adventures await. Remember, understanding AI empowers you in this digital age. See you soon.